Hello and welcome back to the stream. I am Jun-chan and today we are back doing some Haskell data structures. And in fact, we have extended our week to work on this, and so we shall work on this until the 19th. Yeah, it just feels that I need a bit more time with this. I haven't made enough progress, so we can stick with it for a bit. So the last thing we tried was to, well, to be honest, I don't exactly remember. So let's do a little bit of the usual housekeeping things and duplicate our logs and then take a look at it. See whether we actually tracked some of the latest stuff. Right, we were having data vector errors, and I was actually trying various combinations of modules, basically. That's where we need to look at. And yeah, I think I upped the bound for the vector module, but then also checked out a particular commit for it, which was 0.10.9. So you know what, maybe that's, so it seems like maybe there's a conflict between 0.12 and 0.10.9 here. So could we simply delete the other version? Or is it a version that's actually in the Nix environment? Could be one or the other. 0.10.9. Let's see, what really is the error here? Could not find data vector fusion bundle monadic, and fusion bundle size. Okay, so let's get back to this. And I haven't really introed anything. I'm just jumping right straight into it. But yeah, that's just how we roll today. Okay, source data vector, and it is in array and map fusion. So in array, we're missing data fusion bundle. So is that true? Data vector fusion bundle. We should have one of those. Data vector fusion bundle. Data vector fusion bundle. So that's a little bit strange. And then data vector fusion bundle monadic. We're also supposed to have one of those. So and it definitely is in the build depends. So maybe it's related to this 0.12 remainder here, but where would it be picked up is a question. If I do kbal info vector, right, so there is something in the Nix store that's 0.12, 0.1. And so, oh, did I forget to add vector back to the kbal project? No, it's here. Oh, no, it's not here. Haha. It's commented out because I was actually sort of trying back from scratch, so to speak. Okay, so definitely wrong version of vector got compiled. Trying back from scratch by installing a version of vector actually that I think is that one that was, it looked a bit strange. It looked like 0.10.9 had some changes that were reverted in 0.10.9.1. So that's pretty strange, but it could be that that's the strange version that actually Ed had in his local compilation environment at the time, because it seems to have the right interface that we want. So it could be that with this version of Vector, we're going to have trouble building some of the other packages that depend on Vector. So that's sort of potentially what we should expect. Right, so hybrid vector, for instance, needs data vector fusion stream, and that's something that indeed we don't have. But here I think we're back to doing something which is doable, because I think what I decided is that it wasn't actually too difficult to convert to the new API. So if that's the case, by the way, there's really no reason that I would stay with the old vector version, I don't think. The 0.10.9, I could swap, I mean, go to the 0.12 or something, which actually sort of finally had that interface. What looked like the moment where it actually remained stable and stayed that way, rather than this weird hiccup at 10.9.0. So I'm not sure. I think I might be in a weird cycle here, and I should document it in order to avoid being in that weird cycle. So let's try and see whether we can document this. Okay, log, sure, why not? Okay, what are we doing? I pinned a checkout of vector 10.9.0 or 0.10.9.0, which has that vector fusion bundle, and the intention is to migrate to the newer fusion module structure. And then the question is, why use 10.9.0 in that case, right? Why not use 12? Maybe because 12 doesn't support the old versions of GHC we're using. Shall we verify that for sanity's sake? That's Lance. It could be that it's actually part of the 0.10.12.0 would have fusion. I see. It doesn't even have the bundle, that one. Right, 0.12.0.0 I think has it. That it does have it. 0.11 also has it. So, right, 0.10.12 doesn't, but it shows up in 0.11, and in 0.11, if once JC prim less than 0.6, and DeepSeek less than 1.5. I think that's actually fine. But I also think I've been moving back and forth with two solutions, and I might be looping. But you know what? I'll just make the effort to document our path correctly right now, and this way we'll avoid looping the next time. Okay, so intention is migrating new fusion module structure. Right, so afterwards we can try using 0.11.0.0, where it appears stably again. Okay, and right, because right now this is going to require from us to upgrade hybrid vectors, and the trouble is that we might not be able to have a hybrid vector version actually, yeah, this is recent. Oh, it's recent, but right. I need to change the detection for the minimum version. So that's it. But it's been developed in a way that allows to use the different module structures. So let's add that to a couple projects, and I think it will be the same for at least maybe lens. So we might have to re-add all of these, but let's do it progressively. Okay, adjunctions worked, so we're now in lens, and so yeah, I suppose we're going to have to do the same stuff we did. Yeah, same trick here. So let's just do that. Pick our project, and let's. Right, that is a big module. Okay, so now let's, since this is going to rebuild, let's zoom out a bit. And what we're trying to do is, yeah, work out whether we could find an API for a range query. And I proposed this to, you know, starting key and key, map KV, and then return a list of key value pairs with the idea that maybe we can make this efficient. I don't know. I've never done this before, so I don't even know how we're going to measure that. But my idea is that, or the thought is that with the list, we should have the fusion and stream-like sort of low-level representations. But that, I suppose, is only if we manage to actually create an implementation that would allow to do that. So, and but that seems to me like a easier pathway than to do something like returning map KV. Okay, we have trouble there because that would mean that we need to rebalance that that strange data structure, and we would cut it against the grain, and yeah, so that would clearly take quite a bit of time to do. So probably outputting it like so would be better. Okay, what do we have? Not in scope. Okay, let's go check out lens, and this is in data vector generic lens. So here 109, and it says, right, okay, yes, okay, yes, that's fine. Same thing here. We can simply comment this out, and we'll need to do this for all of the main vector. I mean, I could probably trick it into thinking that that we are version 11, but I'm not sure that that's the smartest way. Yeah, no, that's not the smartest. It will come and bite me in the ass later. Oh, not in scope. Fold the ring. Oh, really? How come? Interesting. Okay, fold ring. Oh, those are rules. Interesting. Huh. Define the vector. Oh, that's one of the ways that we could have done it, I think. Vector blah 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 blah. Fold ring. Yes, indeed. Where is that coming from? And are those rules going to be important? They are about vector traversal. Which is another way that we could play, by the way, with the map interfaces, is to create a traversable instance, and maybe a lens traversal by the same token. So to do that, we need to have fold ring. Okay, fine. Let's try and search Google for this. Control S combinators, Control S fold. So that's supposed to potentially come from Control Lens fold, but we don't have it yet, so maybe we add it. I suppose that's what it is that we don't have it yet. We have folding and fold, yeah, but not fold ring. Oh, that's fold R ring, right? And this must be the fold L ing. I see. Funny Ed. Okay, let's take a look at it though. Folding. Let's look at the signature. Foldable, indexable, contravariant, blah, and an over. Yeah, that feels a bit different. But it might be because the interface evolves quite a bit, because we are in like a archaic version of Lens right here. So let's check out something that's more around that version number, 4.9, and 4.9 contents, and this is version 5. So let's see, let's pick 412 just arbitrarily, and then fold, Control S fold, and check out what we have here. Fold R, yes, we do. So we have it at version 412. So you know what? Let's duplicate that and then try and see whether we can go back in time like this. Fold R. We don't have fold R, fold ring here. Okay, and so well, look like I just picked the right version for some reason. Yeah. So contravariant applicative lens like, is that going to serve our purpose written like so? Might not, because for instance, oh no, it might, yeah. Folding, that's a lens like, not a fold, but and folding is a fold. No, that looks like that's actually what we want. So let's add those. I fold ring and fold ring. Oh, we need to export those. Oh, not in the right place. Okay. So what do these do really? I mean, they fold from the other direction. So they expect an F that's doesn't need to be foldable, just need to be contravariant and applicative. Type signature is quite different. And returns a lens like. and we use this in rules. What are rules? The rewrite rules. So vector traverse become mapped for VA WB if V is the same as W here. Is that what it is? Rules. So one is the rule name in strings, and then example inline rule. Same pattern for any function. Okay. Rule map -1 looks like some kind of priorities, order of rule matching. Okay. Oh, yeah. 2001. Oh boy. Okay. See what was fired. Syntax: 0 more rules. Layout rule applies. No new indentation level is set. Each rule has a name. Optionally has a face control number. Okay, so that's what that thing was, but we don't have them. Variable mentioned in a rule may either be in scope or bound by the for all. I see. We don't have for alls here, so vector traverse is in scope. Sets must be in scope. That's why it wanted following to be scope. Call the pattern variables. Okay, separated by space, but we don't have them. A pattern variable may optionally have a type signature. Okay, so that's this, for instance. Okay. Left-hand side of a rule must consist of a top-level variable applied to arbitrary expressions. For example, this is not okay. Case and f true equal true. In wrong one, the LHS is not an application. Vector traverse is an application. Okay. LHS is a pattern variable in the head. A rule does not need to be in the same module of the variable it mentions. Yeah, all rules are implicitly exported from the module. So that's the syntax. Rules are enabled, blah, blah, blah. Maybe switched off. Tries to apply the rule as it optimize the program. For instance, consider blah. Expression st access does not match the rule map. But GHC will substitute s and t, giving an expression which does match. Map f blah map f gjs. Okay, yeah, so that's to avoid doing two traversals. There's a composition rule. Okay, well, so I think what matches, what's supposed to match here is that's the result type, or is that the type of v.map? I think that's the type of the whole thing. We are in GHC 704 here. let's look at, oh, there's not 710. Yeah, there is 710, 710. Docs, index. Okay. It looks like we need to go to 710 again. Okay, HTML, and here we go. User guide, rules, not costs, rules pragma. No, so no, that's specialized. Okay, rewrite rules, and we are 710. Okay, and looks very similar. Yeah, I don't think this changed. This actually rules is used to implement Fusion. I see. Vector traverse. Let's check out the type of an index traversal. Maybe that will. It's probably hard to read. I see. So it's vector indexed by an int. Yeah, this looks like it would convert to a list, and then from a list, and yeah, imagine those aren't. I mean, there would be a cost in the to list from list anyway. Okay, well, not completely super clear, but I suppose this means if there is an instance a setter, such as for VA, VB, AB, then use sets out map. So it's an instance-based pattern matching of sorts, I think. But I can't quite exactly figure out what it's like. What does the following documentation say here? Obtain a fault by lifting fold R like function. Using this combinator, folding and fold R. And it can also fold with index. if we get an int and an endo_r instead of a vector. I don't know why there's two vectors here. Oh, it's a lengthy thing, I think. They can be the same, and then it's just a setter. Or, well, no, actually, not the. I mean, the same structure, but different input and output type. If it's endo_r, what is r? So it's for all r. It's a function from r to r. That sounds like ID. So it's just a way of just traversing a single vector without like the monomorphic version, maybe then, or the non-type changing version. Maybe that's what it is. Hey DK78, nice to see you. Sorry, I just saw your message. I'm doing good, like on the tangent to try and understand this set of rules there while I was just fixing compilation errors and trying to understand these instances as well. Of probably an attempt to try and make this vector traverse run faster for certain specific use cases. So I think I got it, but yeah, it's oh, you just sent it. Well, then the corner of my eye picked it up at the right time. Usually I'm not so lucky. Okay, what's up with data vector map fusion now? Ooh, so now we're compiling our own, well, not our own, but the module we want to compile. So that's good. How's it going with you, DK78? What's up? What have you been up to today? Okay, data vector map fusion has right. So this, I think, indeed I need to think about this a bit. So first of all, I changed those. They were before. Yeah, so these, I think, need to be reverted back to what they were, I think. Yeah, I think so. So we do this and we try again. And then you need some, okay, now you need just 2 max. Oh, good, excellent. CS50, what is that? Is that computer science something? Ooh, nice. Awesome. Intro to CS, very cool. Which module are you on? 34. Right, I think in this case this isn't stream anymore. I think this is actually bundle. And the way that I think, right, so we did take a comparison somewhere here, yeah, of when and how to move from the old module structure to the new module structure. And indeed, in that case, we change things that look like stream A to bundle VA. And in Fusion, the problem is that this doesn't look like this. It actually looks like it was written for the more recent API. So we have stream MKA, because I think stream does take to two parameters, but let's verify this. So I think it would come from stream monadic, right? Yeah, I think so. This exports a stream, and stream is defined as stream MA. So yes. Still on new friendly mode, introducing fundamentals. That's good. Excellent. Excellent, excellent. Yeah. Okay, so I'm down in the weeds. Still trying to make this this module compile, or this this project, which is a structures, not structured graph. Edward Met's structures module, which is it's a little bit tricky to compile because it's 7-8 years old, and so I've been having to sort of time travel and pick library versions that make it compile. And so in the end, it means that for a week I've been just playing with, struggling with. Playing is not sounds like fun, and it's not exactly fun. Although I do learn stuff, but I've been struggling with trying to make the module compile so that I can finally look into how this thing works and whether I can use it and maybe modify it and augment it just as a way to improve my understanding of this particular data structure, and then also how in practice these type of data structures are used in Haskell. So that's what I've been up to. And right, so stream MA here, and what does it say? We're missing some toMax function. Okay, that doesn't sound like so terrible. Where is that toMax function used? It's used with NA, and NA is something that is pattern match from the stream. So let's go check out again what the vector implementation said for which the monadic stream, right? So the third constructor in stream is oh no, not bundles. There we go. Stream is so it's so sounds like if you pattern match on a stream, would only have two things: a step function and an S, which would be a state. Isn't that the case? A step, and then so this N, I'm not so sure. This might not be coming from the right library version. This might be a size, and I'm not sure we need that size anymore. But we do import Fusion bundle as stream as well. So let's go make sure that we're not using, no, this is bundle, right? But does bundle, if we pattern match on bundle, then it will be a m.bundle ID because bundles are here, and bundles have an A in there. No, hold on. Bundles have more than that, but they're in a record. And they have actually 4 parts to them. So I don't think that's what we want anyway. If we changed stream to bundle, I think we would be struggling quite a bit because these are fairly different. So monadic stream is what we want. Seems like. However, when pattern matching, we will not we have the step function, we have the state, but we won't have some int. But there is, yeah, I have to admit, the concept of the length of a stream is a little bit weird in many ways. Anyways, it is a little bit weird. Suppose they are streams that can be terminated though. Well, yeah, because the step function has a done. And so here, if we reconstruct a stream, then so potentially we just remove that and we carry on. It's quite possible that that's just what it is, but I want to double check by taking a look again at the well, at the change of API between the two versions of vectors. So let's see, compare. It's not this. Compare. So this is only for lengths, right? Yeah, so this is for lengths when moving from one version of vector to the next version of vector, and it uses data vector fusion stream, whereas here we already use data vector fusion, well, stream monadic. Is there somewhere else where we use another version in this library? Let's see. I think if so, it would be in map. And here we do use data vector fusion stream monadic. And so when we pattern match, if we pattern match at all on streams, do we pattern match on stream? Yeah, we have a stream here. We return a stream here. So we won't be pattern matching on it. We just construct them. Interesting, actually. I wonder if that's what we want in our interface. I should make a note of that. Didn't want to do that. Do we want to return a stream here? Maybe we do. Yeah, we import monadic from stream. And what about the amortized, or actually ephemeral? We also use the monadic version. How about here? Do we also just construct, or what? Yeah, it seems like we only construct here as well. So it's only in that fusion thing that we consume, which I suppose makes sense. Except that it's a bit of a bummer that the interface seems quite different. And also here we do stream m of ka. Do we produce something like that? Yeah, I think so. Yeah. Okay, I mean, this seems like that's actually a pair, but and here, yeah, AB. Okay, yeah, it must zip a vector of keys with a vector of values. So I think that also probably makes sense. And so okay, so the other thing I can do then is well, to be honest, this seems like this is just about streams. Shouldn't this be a library function in the maybe not, because it needs to know about a stream of a pair of something that's a key with an order, right? Yeah, so it couldn't be a library function for the vector fusion library. Okay. Hey, Shadow Suburbia. do I do C++? Well, I do not. I do Haskell right now. Yeah, C++ is a language I haven't done much of. But I hear that the topic that I'm playing with today, which is cache oblivious data structure, is something that's actually fairly commonly known in the C++ community, whereas in the Haskell community it is not so much, except for the efforts of Edward Met to actually introduce us to it, and that's why I'm trying to study this from closer after seeing a few presentations of his. And do you do Haskell, Shadow Suburbia? I suppose it's not Shad, it's Chad. Right, so I'm inclined to think the new version of the API simply doesn't need a length. And then in that case, we're all good, and we're just done. So let's see how Vector did its thing. Right, so this is a new version. So let's see how I did this thing as version 0.10.9, even version 0.10.9 1, I think will be already different because it's switched back to the old version. So if we go to Fusion, and I think just trim, to be honest, right? Yes. Then we should see that it has a length, and let's just confirm that. Oh, so that's still coming from stream monadic here, and look at stream. Yeah, that's right. So it had the size, and it's just been removed. So you know what? That's enough for me. I think I'm convinced I understand this correctly, and I can just remove the size from the constructors, and probably also in insert. The API has evolved in such a way that it doesn't need the size anymore. So that's great. Let's get our build. Okay, next error. Data vector fusion bundle is redundant, except perhaps import instances. Okay, but that would be just a warning, so not a problem. And data vector array. Non-scope data constructor p.vector. Okay, what's that? Oh yeah, well, oh no, hold on, array. P, data vector primitive. Okay. So yeah, that's all the prefetch stuff. So you're saying, oh, there's PM vector now for mutable vector in data vector primitive. I see. Well, I suppose we're going to have to take a look at that too then. Right, primitive now has mutable and it's just M vector. It's just M vector, but is it going to be the same as vector? Well, I suppose we can take another look at this, simply going into data vector primitive mutable and see whether it was called vector before. No, it was called M vector. That might be after. So let's take a look at 10.9.0. Still M vector. Oh, but that's data primitive mutable. So is there a primitive .hs here? There is. And is there a primitive .hs here? There is as well. Okay, so, and this has a vector, right? It exports, it does export vector, data vector primitive. So what's the NM vector 2? Okay, so what's the deal? P.vector. No, I do not. I do mean P.vector. Okay, what's wrong? It's exported. It has this stuff, and in array, data vector primitive as p and primitive mutable as pm. So p should be p vector, and so you say 143. Yeah, p dot vector right here. How strange. P. You're compiling data vector array. No, I do not mean p.m vector. Why are you not compiling? Why are you not finding data vector primitive, which has vector in it? How strange. Oh, yes, the only reason why it wouldn't be in there if it wasn't properly exported as a module from here. But it is data vector primitive mutable. Those are exposed modules, and there's really no reason why I shouldn't be able to see them. Unless, again, there's something with the version somehow, but no, I don't see why. I don't see why at all. Data the primitive is primitive, and p. That's strange. I feel tempted to cabal clean, but I'm also a bit worried about compilation times. Why is it not in scope? As vector. Okay, just sanity check. Data vector primitive.hs and just vector, and yeah, module. We export vector and we define data vector blah. PM has m vector. Okay, we actually don't need PM because primitive exports m vector. So let's just do without. This is really strange though, but let's just do without mutable, and let's just say SP, and then let's just fix the PM to BP. And see how that goes. Still not happy with p.vector. I fear that's because there are two vectors, two ambient vectors, vector libraries. Okay, maybe I need to be saying this. Same error. I am afraid I need to clean. Clearly should be there, and yeah, it's going to build vector 0, 10, 9, 0, which is what we want. And yeah, it's gonna have to rebuild lengths and whatnot, but it's all good. We have stuff to do. Yeah, because now we know that maybe we want to export streams. So actually identified, while doing those changes, identify a pattern here, which is that some of these functions export streams. So map has a zip that exports streams from a chunk. And then this is used, I think, internally, right? Yeah, it's used here for merge of chunks. And merge is, again, used internally, I think. Yeah, for insert. So obviously quite important. Right, so that's the low level. Oh, that's the actual building of the, that's the actual resolution of the thunk of the A's and B's into the combination of the A and B that's held here as a lazy value, whereas everything else is strict. Yes, yes, yes. And such that when it finally gets evaluated, then I think at some point, that there's a bit that I'm missing maybe, but I think at some point it just gets into the next, yeah, it just gets pushed into the M1 of the contained LA. I think that's what occurs. Yeah. But so that merge is actually such that it should build a chunk of the size of the combined size of the first two strict variables here. So let's try and see whether we understand this correctly. So it's really good that, in fact, merge is used here and streams are used as an intermediary data structure, because it means that that clearly would have to be tuned for high performance, because it's an internal operation of the data structure, so it would need to be occurring fast. So so that should teach us something about how to do something fast with the internals of this data structure, and maybe then see whether actually exporting streams, maybe even as an intermediary before creating a list, or even maybe just as a potential output of a range operation, how that would work. Okay, so merge Asbs is literally the thunk that is supposed to merge A's and B's. And so how can we tell that A's and B's then will be at the will be concatenated, I suppose is the one way to say it. So we can't tell by the type because it's unsized. And so what do? First we g unstreams zips as blah 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 blah. So we zips b's. Oh right, okay. We fusion merge zips a's with zips b's, and zips a's give us a stream ID kv. So zips a's should be a fairly fast, I hope, transformation of A's from chunks to streams. So let's try to evaluate how it's able to be fast. Takes the chunk, gets the K's and the V's, which let's refresh our memory here. The K's and the V's are chunks are here, right? No, chunks maybe are in map actually. So they were defined just up there. Yeah, chunks are just an array. But an array is this. An array is RAA. Right, where the first A, I think, is just a type. It's just used to get this array class, I think. It's just a almost like a singleton type. It's the thing that's being pattern matched on to choose a prefetch instance. So if we have an array of unit, then we pick this. If we have an array of double, then we pick this. But then, yeah, then we ignore that first value. If that even means anything. Yeah, and they can be mutable, but let's look first at the non-mutable version. So chunk is just a strict array of keys and a strict array of A's. So that's it. We just pattern match on them, and that should be virtually costless. And then we stream K's and V's and zip them, thus constructing a something that is not directly it is here, just constructing a stream ID KV of a tuple of KV. So ID, I think, is the identity monad, because streams can be monadic. And so yeah, so that's actually why we have data vector fusion stream monadic here, because it's stream MA, such that, and holy moly, this is the monadic stream function from Dunai. This is the same thing as of M of a step SA. Yeah, almost. It's not exactly the same because it's not a stream inside, it's a step. But this is pretty much also, I think, how the this is the run streaming construct, except maybe without skip. But the pure screen run streaming has this. And look at this. Looks like we bumped into the exact same error. Don't see p vector. Okay, let's cabal REPL. Is that even gonna work? No, it's going to try to. Ah, yeah, no, it seems to work. So if we import data.primitive, data.vector primitive, and we browse data.vector.primitive, you're telling me that there's no vector in there. Okay. Oh, right. Ooh, that's not good. Okay, so I want data vector. You do have data vector in there, right here. Hold on. Is the constructor exported? Oh, it's not. I see. That's what's happening. Constructor is not exported. Why is the constructor not exported? Okay, well, let's see whether well, it explains the error, but how am I going to evaluate this? I'm going to look at where it's in use and remind me. in data vector array, and that's for right, so we can reestablish pm.vector, pmp, there we go, and then go to p.vector here, and here we pattern match, and this is for the prefetch prim for prefetch prim 0. Which are then used over there, okay, and I take a vector, an index, or yeah, I suppose, and the current state. So that sounds like that's for mutable vectors. If there is a state, it doesn't. But these are low-level internals, so it might be a little bit different. Did the card making machinery change? What is this? A state hash. Maybe that's just the internal state of the runtime somehow, like state of the world or something, like for the IO monad. Maybe. So in that case, we shouldn't worry too much about whether we are in a mutable thing or not. So prefetch prim blah, and we should just worry about whether the constructor is correct. So let's just go check it out. It is in well, we can check it out here. It's actually, oh, except, oh no, yeah. Data vector primitive takes an unpacked, two unpacked int and a byte array. Yeah, that looks totally correct. Okay, so let's just export the thing and not worry about it. Yep, just compiled. No, it's recompiling vector, of course, because it needs to export constructor now. And a bunch of dependent things, but it's smart. It can do module-based dependencies here, not package-based dependencies, so it's only rebuilding the correct packages. That's good. I'll drink a bit. Okay, and so map. Right, we were thinking about our streams. Right, so zips is just stream zip. So we need to know what stream zip is, and that is part of, I believe, this zip. There's some rules. Okay, zip, 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 zip. Zip is zip with tuple, and zip with is zip with m of some function, so tuple for us, and zip with m is right there. Takes the f. Okay, hold on. Zip with m Yeah, okay. Yeah, f is the function, so for us it's toppling, and then takes the two streams, and then returns stream step, where step is taking the state of the left stream, the state of the right stream, and right, so I need to refresh my memory about what the step function should be inside a stream. And step function should be something that takes the current state and returns wrapped in the monad the step constructor. So either yield, skip, or done. Yield meaning given the current state, so I suppose it's given the current state and an A, just yield that A, otherwise skip and do not yield anything. Okay, good, we have new errors. But let's continue this for a bit. Yes, so let's go back to our zipping and zip with them. And so what's this? That sounds like the initials. That's the constructor for stream. So in addition to SA and SB, with zip with them, we also output we also construct a tuple with nothing in it. And that's not the F tuple, that's a internal tuple in the S. It just occurs that we apply probably F to SA, FB at some point, like FXY. Yeah, we'll get it. Okay, no, I'm not clear about what that is exactly yet. Okay, so let's try and run through it. We I think this is a starting state. So this stream is just a stream with some additional metadata, which I suppose, well, we'll see what it is, but probably something to keep track of when one of the streams has finished, maybe. I'm not sure, but okay, let's say we start, we have nothing in there, so definitely we do. So we have an SA, an SB, and nothing. So what do? Then we lift M, because we need to be in the wrapper monad, of a function that takes a state, and then depending of, well, it actually takes a step function. No, it takes a, yeah, it takes a state and then yields a step constructor. So this is the S to step signature from stream, and so the step, depending of whether the R that the new stream, the combined stream, receives, if it is a yield X SA prime, then that stream will output just X. So this is a slot for the yielding of the combined stream. And it will have a new SA prime. Does this mean that this is biased somehow towards the left? It probably does mean that. even though here it looks like now we got SB prime. But let's look at the documentation of zip with M with later versions of data vector fusion monadic, because we do have this around. And let's look at the very latest. And data vector fusion, so stream monadic. And zip with zipping and zip with zip to streams with the given monadic function. And looks pretty much exactly the same. Oh, and it's given a step A essay. Oh no, I think I get it. This is a way to, if it's nothing, then we're on the side of the SA, and if it's just, then we're on the side of the SB. And it just alternates between the two, making sure that it takes one element from each stream. And when it gets the SA, if the SA has yielded, then it passes the X, such that if SB also yields, then we get an X and a Y, and we can yield Z. And otherwise, we just skip, and I suppose, I wonder whether then maybe we wait until, I wonder how that works, what the semantics are here. So let's say A yields, but B skips. Then in that case, we keep the X that has yielded. And so does this mean that then, oh no, then it means that we re-enter, or then we wait until B yields as well. Okay, so the synchronization is done through this nothing, through this third member of the tuple. Oh, that's cool. And so if the first skips, but then the SB yields, then what? Oh no, well, the first skips, then we continue until we yield. I see. Yeah, okay. And so in theory, this actually becomes a tight loop. That's pretty surprising, but I suppose that's the case. But yeah, I can't help but see the huge parallel here with the implementation of PureScript run streaming, which also has monadic streams, but in this extensible effect language. But here we have we have a step, which is a different beast, but where is it? Ah, yeah, right, it's the resume that I'm thinking of. That is a little bit equivalent to the step here. The resume data type is something that sort of allows to, where it doesn't allow skipping. So I suppose here you don't have the way to have sort of desynchronization of sorts here, where the stream might not emit on the same tick. I'm not even sure what that means in that case, by the way. But I suppose since the streams have this semantics of being able to skip, I wonder if it's to represent actual asynchrony at the boundary, meaning as a actual streaming data structure. like some kind of weighting. Which feels like introducing a side effects inside your data structure, but I think that that's the type of things that that Haskell does. In fact, I wonder whether that skip isn't related to the slow here. Like the way to wait on something. Now I think in this case it was to wait on like the kind of the cost evaluation, like the amortization of the data structure. So probably not like that, but not completely unlike it either. Okay, let's go back to our compilation. What do we mean here? Oh, those seems like just GHC things. It should be okay. 6 of 9, data vector map. Let's go for it. Data vector map. Not in scope, data map, internal debug show tree. Okay, well, that's great. That's actually something I was writing, so we can just comment it out, because if that's where it fails, then we probably close to our goal, but not quite there. Couldn't match type data vector fusion bundle monadic bundle. Okay, yeah, clearly we don't want bundles here, in fact, or do we? What's up there? Data vector map 128. Zip. We're looking at you. Oh, I remember bouncing off that error message last time, but now I've looked at the implementation and I know what it means. So stream IDK, so it's just that G dot stream expects these types because G is data vector generic. Oh, is it? Is that what it is? Maybe not exactly. Hold on. Or is it that zips? What is it? 128 is zips, and we're expecting stream ID K, which I suppose zips A's should be stream ID K, and then zip yeah, 48 zips B's should be stream ID V's, but oh, that's because of fusion merge. Yes, so fusion is taken from data vector map fusion, and if we look at data vector, oh well, data vector map, oh, my data vector map fusion is right here. Then, oh, then we see that it's not with monadic streams, it's with bundles. But is it? I think we're talking about fusion merge right now, and so maybe we do this. With stream IDK in the expression stream zip, so it's stream zip that's the issue, and stream zip is in stream monadic, in fact. So we just need to use the proper stream zip and not the one from bundle. And well, we should when we do this. So what's up? Stream zip is not correct here then. Stream.zip takes a stream MB, returns a stream MAB. And oh, that's what you expect, but what you get is a bundle. Okay, so now I get things in the right order in my head. So you are saying that your zips A's is in fact a bundle. Well, I would like to challenge that because, oh, hold on. No, because your g.stream K's is a bundle. Okay, so that I will consider, because data vector generic G, data vector generic, we do g.stream to construct our stream from arrays. And so stream okay, stream and partition stream and stream and stream. Bundle from vector. Well, yes. Indeed, it is a bundle then. So, but you will have conversion to and from stream, monadic streams as well, right? Or you would have conversions between bundles and streams, right? Util. Util does not, and bundle. So it does import stream monadic as S, and in place takes something that converts a stream to something that converts bundles. Oh, I think I understand the signature change now. Is that streams don't have sizes, whereas bundles do. And it makes sense because you don't want streams to have sizes, because that's confusing, and I was confused by it the other day. Makes sense. Okay, so so now we need to either well, I suppose, yeah, we did remove now our merge operation. I suppose our merge operation could take bundles. That's one thing, because in fact maybe that's the better interface, right? Because we kind of need this size, don't we? Because these are actually arrays. Yeah, I can definitely buy that. So in that case, I revert my my changes, and we call those data vector fusion bundle and bundle size, and I think they're actually bundle monadic. Yes, and then, however, we call those bundles. And is that gonna solve everything just like by magic? It's not impossible. Sometimes Haskell does things like that. data vector map fusion, not in scope data constructor stream. Yes, indeed, we need to change a few more things. I don't even know whether, I think in fact we know that that's not the right type signature for bundles. That's, I think, data vector map fusion, not in scope data constructor yield. Because that's part of monolithic streams, but not of bundles, monolithic bundles. Well, in fact, it isn't. I wonder whether Ed actually wrote this as he was writing structures, and this came out of the structures work. From stream size a bundle. I see. So in fact, a bundle has elements and chunks. But you can create a bundle from a stream by passing it a size. So that's useful. So in our case, what do we want? So I'm going to write this down because I'm going to do it tomorrow. But in our case, what we really want is we want our zips here to, we want to be able to construct, well, streams or bundles, but probably bundles from arrays using the data vector generic g.stream, which creates bundles, which makes sense that it creates bundles because it's obviously not of infinite length. But it encapsulates something of infinite length, but presenting a proper interface for it. Okay, so let's write this down. So that's what we're doing. So now now upgrading the data.map.fusion code, data.vector fusion code in structures to would be so g.stream takes an array, which, yeah, under the hood we kind of think is a vector, but it takes a it's a data.vector.array, which is like this structures thing, and creates a bundle for it. So but we expected a stream, so that's sort of one of the things, right? And is it fair to say that an array is a vector? With this strangeness? Probably, huh? It probably is. Okay. And here this data vector fusion bundle is imported as stream. Used for stream equality. And that's it. So we have a bundle here, and so we'd want to bundle zip. That's, in fact, that's pretty much it then, because we have bundle zip. Okay, change of plans. Looks like maybe we simply need to say bundle monadic as stream, and then not make those changes that I just said we should do, or we could do. All right. Data vector map fusion. Yeah, that's right. So you simply don't need that. And then you need the 2 max. No. Well, yes, okay. Damn, I reverted too far back when we still had our sizes. Yeah, I feel like I'm going to need to go back to actually having the sizes there, but because we probably want these to be actually operations on bundles, but for now, let's try like this. And yeah, that was a oops, too big of a delete. And right, we're close, but still no cigar, because we want this to be bundles. Yes. So really the next step, so we solved this, and now data vector map fusion dot merge. Needs to be updated for bundles. Merge and insert. Okay, and that's what we'll do next time. So thanks a ton for watching. I was Junchan, and we see each other on Thursday for more cache Oblivious data structures in Haskell. Thanks and bye-bye.